So number one, you're going to write something for me, huh? Fats and oils are organic carbon compounds. Okay, you might be wondering, you don't take bio, how come? But in chemistry, memang it's in the syllabus. You have to know this, huh? Okay. Fats and oils are organic carbon compounds that contain, put down a carbon, hydrogen, and oxygen elements. Okay, all right. Fats, oils are organic carbon compounds. So this is our syllabus, huh? That contain carbon, hydrogen, and oxygen elements. Okay, we know that in bio we learn, huh? Okay, then number two, fats can be found in animal and human tissues. You don't find fats in plants, huh? All right, that is oil. When I say fats means I'm talking of solid fats. Okay, these are all the animal fat. This is chicken fat. This is the fat. Can you see that? Found in the, maybe the, could be a piece of beef or mutton, right? And this looks like the fat found in pork, huh? All right. Okay, these are animal fats. Okay, all right. When I say oils, okay, these are also fats, but we call them as oil. Okay, usually found in plant seeds. Okay, all right. Nuts. I mean, I say groundnut oil. Have you heard of groundnut oil? Huh? We have peanut oil or groundnut oil. Corn oil is very common. Okay. Coconut oil, yes, we have oil from coconut. Because we don't use it for cooking. The coconut oil is used for as a moisturizer and all that, huh? For your skin and all that. Palm oil, we know, huh? Definitely we know palm oil. All right. We have that in Malaysia. Okay, then we have soya bean oil. Yes, soya oil. All right. I'll zoom in a bit, huh? That's your soya oil. Can you see that? Oil from the soya bean. Okay. This is olive oil. Can you see here? Olive oil. Look at the picture. Olive oil. Okay. This one is groundnut oil. Okay. All right. This is sunflower oil. Sunflower seed oil. They take the seed of the sunflower. Okay. And then this one, I'm not sure what it is. Okay. This is corn oil. This is coconut oil. Huh? Okay. We have many, many types of oil. All these are healthy oils. You know. Okay. Even palm oil we have from the oil palm fruit. Huh? Okay. So when I talk of oil, I'm talking of liquid state. When I say fats, I'm talking of solid state. Can you see that? When I say fats means solid state. Again, please, monitor for both the classes. Please take the attendance. Inform those who is not present only. Okay. Any questions so far? No problem. Fats and oils. Okay, settle with that. So animal fats exist in solid state. Write that down first. All this animal fat, all this fat found in animals. Solid state. Oils exist in liquid state. Highlight that one. Okay, oils is in liquid state. Animal fat in solid state. You can highlight. Oils in liquid state. When I say liquid state means at room temperature. Okay. So you take the oil, you put it in the fridge, in the freezer, it will harden, you know. Okay. At room temperature. Yeah. Right. So we come to our lesson. Okay, we have already learned about ester. How you get an ester? Okay, let's check. Jasmine, are you there?
Yes.
Okay, how do you produce an ester? Tell me. What you mix?
Through esterification between alcohol and carboxylic acid.
Okay, the process is esterification, correct? Alcohol and carboxylic acid. Okay, so I put here. See, this is important. Fats and oils are natural esters. Write that down. Okay. That is formed from the reaction between, okay, now this is a special name, all right, for this alcohol, and there's a special name for the carboxylic acid. We call it fatty acid. Write that down. So the spelling is here. From the reaction between, you don't go put carboxylic acid, it must be fatty acid. See the word glycerol, OL. What does that remind you? It reminds you of an alcohol. Fatty acid, it reminds you of a carboxylic acid. Okay, so but you don't take carboxylic acid and alcohol to get fats and oils. You understand? You have fatty acids, which is actually a carboxylic acid, and glycerol. Okay, all right. So this, when I say triglyceride, this is actually a fat molecule. In biology, those who are taking biology, you know what I mean. It's a triglyceride. Okay, that means what is a triglyceride? Okay, note it down first. Can you see fatty acids here? 3 molecules of fatty acids combined with 1 molecule of glycerol. Can you see that? This is 3 molecules. 1 molecule, 1 molecule, 1 molecule. Combined with glycerol is 1 molecule. 3 molecules here, and the whole thing becomes a fat. In chemistry, we call fats. In biology, we call lipids. Okay? So put down here, this fatty acid is actually a carboxylic acid. Note that down. The fatty acid is a carboxylic. CARBOXYLIC, carboxylic acid. And then this glycerol, you see the word OL there. So it's actually an alcohol. Okay, continue. All right, so this whole thing is a fat, which is an ester. Because when you have a reaction between an alcohol and a carboxylic acid, you get ester. Okay, but of course, it's a different type of ester. All right, they don't have any, they are not sweet smelling like the esters we found in the fruits and all that. Okay, in the flower extract, all these are sweet smelling. This one different, Animal fat, you go and smell and see. All right, there's hardly any smell down there. It doesn't smell nice anyway. Okay, so I put the word fatty acids and glycerol. So we're going to look at this in detail. Okay, ready? What is a fatty acid? Okay. Once in SPM, it came out when I was marking last time. Okay, when I was at government school. What is a fatty acid? They asked in one of the past year questions. The first said, an acid. Okay, wrong, one joker even went and said, an acid which has to go to a slimming center because it's very fat. Also wrong, okay? So fatty acid is actually a carboxylic acid. All right, it's a carboxylic acid. Can you see that? But has a long chain of carbon atoms. When I say carboxylic acid, we learn, okay, ethanoic, methanoic acid, ethanoic acid, 2 carbon, propanoic acid, 3 carbon, butanoic acid, 4 carbon, 5 or 6. But this one, can you see? Very long hydrocarbon chain. Carbon, you can see single bond, all very long. Let's count and see 2, 4, 6, 8, 10, 12, 14, 15. 15 carbon atoms. So we don't call it carboxylic acid, we say fatty acid. But it actually is it's a carboxylic acid because it's got a functional group. Can you see the COOH? Okay. So what if they ask you what is a fatty acid in the exam? It's a carboxylic acid that has a long chain of carbon atoms. Please highlight that one. Okay. And then the fatty acid also have a functional group. Okay, this is a COH. Satish, what's the name for this? Give me the name. Satish, are you there?
Carboxyl.
I can't hear you. Can you speak louder?
Carboxyl.
Okay, carboxylic acid. Write that down. CARBOXYLIC. CARBOXYL, carboxylic acid. All right. You can see because I've got the COOH group here. So how do you identify a fatty acid? Look at the diagram below. So can you see that? Okay. So what? Okay. So you're going to go. You can see one line here and another line here. So here you're going to put this word. All right. Long. Write that down first. Long hydrocarbon chain for this answer here. Long hydrocarbon chain. For this, Okay. That means the hydrocarbon is, okay, just let me use my drawing tool. The hydrocarbon is actually from here. You can see hydrocarbon until here. Can you see that? Inclusive of your carbon and hydrogen. So you can see it's a long hydrocarbon chain. Because there's all H attached there. So that's why I put long hydrocarbon chain. Okay, then this one, what is this? You're going to answer that one there. Okay, for this one, what do you call it? Okay, you just put down here. All right. What is this called? Carboxyl group. Write that down first. CAR. Okay, write it down here. CAR. Continue. Right now. CARBOXY. All right. CARBOXYL. Carboxyl group, which is the COOH. Okay, it's very clear. Okay. So that's how you identify a fatty acid. You can see if it's more than 10 or 11 or 12 or 13 like that, 14 or 15 carbon atoms. Can you see? Then it is not a carboxylic acid. We call it as a fatty acid. but it has got the hydrocarbon chain and it has got the carboxyl group, just like any carboxylic acid. But we don't say carboxylic acid, we say fatty acid. Understand, huh? Okay. Next question is this. What type of a fatty acid? Okay, there are two types of fatty acid. Okay, I want you to see here. Can you see all single bond? When we studied alkanes, what type of hydrocarbon? Jaying, what type of hydrocarbon are alkanes? Jaying, are you there? What type of hydrocarbon is alkane? Elisa Lee, can you answer my question?
Saturated.
Saturated, isn't it? Saturated hydrocarbon. So as you see here, all single bond. So write down saturated fatty acid. Write that down first. Here, this answer. Saturated. S-A-T-U-R-A-T-E-D. Saturated. All right? And then you put the word fatty acid. Saturated fatty acid. Why fatty acid? Long hydrocarbon chain, carboxyl group. So I circled that carboxyl group. So it's a saturated fatty acid. Okay? All right. Can I clear the drawing? Okay, we'll go to the next part. Wait, let me just remove this first. Any questions so far? No problem. So you know how to identify a saturated fatty acid. What is a fatty acid? You know. And fatty acid, there are two types. One is saturated and unsaturated. We're looking at a saturated fatty acid. How you know? All single bond between the carbon atom. Can you see? All single bond between the carbon. Okay, can I continue? Okay, so let's go next page. Then let's look at another type of fatty acid. Is that another type of fatty acid? Okay. And you see, there is single bond carbon. Suddenly there's one. There's a double bond here. Okay, can you, if you have a highlighter, can you please circle that double bond? There's the double bond here. I might use another color. Let me see first. I'll use black. Okay. I'll use red also again. Okay, that's one double bond here. You circle that. That's all single. And then this also got a carboxyl group. This is a normal CH3. Can you see now? The moment you see a mixture of carbon single, minimum of one. Sometimes they only show one, sometimes they have more than one. So this one we call it as unsaturated fatty acid. Write that down. What do you think is the name for this fatty acid? Remember I told you alkenes. So unsaturated. Remember alkenes are unsaturated hydrocarbon. This is unsaturated fatty acid. Okay. Right. Now I want to ask you something. I'm going to wait. Okay. So far okay, All right. Just give me 1 minute. Okay. Some of you are still entering. Okay, I want to show, I'm going to go to Google. I'm going to show you something first. Let me just clear the diagram first. Okay, I just go to Google, then I'll share with you. Okay, just give me 1 minute. Okay, let me share this image with you. Just put some images here. Okay, all right. Put a new share. Okay, have you seen it before? All right, have you all seen this before? Jiao, have you seen this before? Jiao? Can you all hear me, no? Can. Okay. You see this margarine, okay. You see the word soft. Why they call it soft? Any idea why they call it soft? Margarine lembut, why? Of course, you touch it, it's soft, you're correct. But if you take and put it in the freezer, it won't harden very much. You take it out, you can still take the knife and just spread it on the bread. Whereas you take a normal planta, I've heard of planta. Wait, somebody is asking me something. Happy birthday, Alicia. Happy birthday, Jiao. Okay. All right. Many happy returns of the day. May God bless you, with success, all the two of you. Okay. All right. What's the difference between margarine and butter? Okay. Margarine is made from palm oil. Okay. Margarine is made from palm oil. Okay. Never mind. I'll answer your question. Okay. Happy birthday. Okay. All right. Okay. Margarine. Somebody has asked me. Sean has asked me. Sean can. Margarine is made from palm oil. Butter is made from the milk of the cow. Okay, butter. Okay, that's the difference. Huh? Okay, what else? Another question first. Okay, all right. So again, soft margarine, but if you see here, sometimes they put the word, if you take this margarine, let me click on it, okay, but they don't show the content, okay. So, okay, let me see further. They don't put here actually, okay. You see, most of the soft margarine, they call polyunsaturated fat. Polyunsaturated fat. Okay, that means when the fat is unsaturated, is very healthy. Understand or not? All right. The saturated fat will be the animal fat and all that. Just now, if you boil it and then you use the oil, that is saturated fat. That is not good. Okay. So the polyunsaturated fat actually was made from unsaturated fatty acids and something else. Okay. We'll go back to our new share, our screen again. All right. We were here. Okay, let's continue now. So what is the name for this fatty acid? Write down unsaturated fatty acid. Okay, get it, Okay, so just now we had here fatty acid, isn't it? There's two types of fatty acids. Okay, saturated fatty acids and unsaturated. Okay, that's what they'll ask in the exam. Okay, now what is glycerol? See the word all there is actually an alcohol. Can you see OH there? This is how this one molecule of glycerol, understand? One whole molecule. It's got 3 hydroxyl groups there. So note it down. It is an alcohol with 3 hydroxyl, HYD, ROXYL, 3 hydroxyl groups. All this alcohol has only got 1 OH in it. This one has got 3. The special name, Okay, so I put here. So here, can you write down here 3? All right, I've circled OH and I put 3 hydroxyl groups. HYD, ROXYL, hydroxyl, which is the OH, Okay. The whole thing is 1 molecule of glycerol. Can you see, All right? Okay. Ready, Okay, so now let's do the formation. Okay, we are going to look, actually it's esterification, Okay, so just like what we did the other day, remember we did chemical equation, isn't it, between carboxylic acid and alcohol. But only one slight difference you see here, this one, Okay, ready? All right, you're going to take a pencil now and do this for me, Okay. Okay, what we're going to do is this. Okay, this is, as I told you, you want to form a fat, we are going to form a fat, a saturated fat. Is that clear? We are going to form a fat. Okay, so if you want to form a fat, you must take 3 molecules, this 1 molecule of the fatty acid. And you see CH3, CH2, 14. You see here, CH3, this is CH3, then CH2. Can you see CH2 14 times? No, not this one, sorry, this one. CH3, then CH2. Instead of putting this so many times, they put CH2 bracket and then they put 14 times. 1, 2, 3, 4, like that. Can you see now? 14 times. And then you see here, followed by COH. So this one definitely must be a saturated fatty acid. So write down here above here. This is above here. Okay, I will show you where to write. Okay, you write here. The word saturated, I put short form, saturated fatty acid. That means all single bond between the carbon. Okay, and then they got a COH. Okay, so this is your carboxylic acid. So you need 3 molecules of this. This 1 molecule, we need 3 of this. Okay, 3 molecules of this. Combine the whole thing from here to here until here. It is 1 molecule of glycerol. I'm going to put like this. Can you see here? Until this. Okay. It's 1 molecule of glycerol. This is 1 molecule of the fatty acid, another molecule of fatty acid, another molecule. Can you see? Okay, get it? 3 molecules of fatty acids will react with 1 molecule of the glycerol. And just like what we did the other day for esterification, the COH, we put it here, the OH, I put it on this side. Remember, I showed you. Okay? All right. So I'm going to clear my drawing now. Okay, let's have a look first. Okay, so we come here now. Can you see? So what I told you the other day, the H from the alcohol or from the glycerol and the OH from the carboxylic acid from here will combine to form water. So what is remaining? Okay, so you're going to do like this, huh? Okay, the second one you can do yourself. Okay, I'm going to show you how, huh? You take your drawing tool now, take your pencil ready, huh? Okay, you write down here, you follow the same level, huh? This thing will come this level, this one will come here, this one will come here. Ready? So I'm going to put like this. Okay, try not to write very big, because you need some space there. Okay, you're going to put CH3. Can you do that first? CH3. Okay, huh? Right, excuse me, I'm using the pen only, huh? Okay, I'm not using the pen, I'm just using the mouse. Okay, CH2 14, okay, you put like that first. CH2, huh? Okay, 14. You follow, huh? Okay, then you have, okay, you can just put like this. COO. You don't need to put a double bond, so you can just put like this. COO. COO. Can you see here? This CO is from here, and then this O comes from here. COO. Can you see that? All right. Then you continue with this C here. Can you see? Okay, you see the C here. Look at my mouse pointer. There's one C here, one H here, and put one H there. Okay. All right. Then you continue. You see this line here. You continue down like that. Okay. Come to this level now. Huh? Come to this level. So you put another C here. This C here is this C. Can you see? Okay, this H is there. Okay. Then you take the same thing and repeat here. Okay. Can we try that now? Put CH3. Okay. Then bracket. You put CH2. This CH2, sorry, huh? CH2, you put a 14 there. Okay, then you put dash, COO, then dash here. Can you see? The carbon must have 4 bonds. Okay, then repeat one more for this. Repeat this whole thing. Okay, I'm going to just put like a square thing, huh? Like a rectangle here. This rectangle will be this one. CH3, CH2, 14. Okay, but you write CH3, bracket CH2, 14, COO. Okay, now I'm going to put the CO there. Okay, now this will be your, oh, wait, drawing tool, huh? Okay, COO. Can you see that? Okay, then dash here, this will be a C. This will be a C, then dash, and then the H comes down. Can you follow me? And then, of course, there's H and OH, so you have 3 molecules of water. So you're going to put 3H2O. Can you see that? 3H2O. Okay, this rectangle represents CH3, bracket CH2, close bracket 14 dash, then you continue with the COO. Can you see? COO. Voila. So this whole thing is a saturated fat, which is an ester actually, because it's, remember there's a CO there. All right? This whole thing. So note down here, this is a saturated fat. Short form, saturated fat. Here we have saturated fatty acid, all right, combining with 1 molecule of glycerol. So you have a saturated fat. So can you do number 2 for me now? Can you do number 2 for me? Don't forget to put all the H here. There's no H here, H here, H, H, H. Okay? Okay, nothing difficult. Okay, I will clear. Can I clear? Right? Or you copy first quickly. So what the next one, I'm not going to put like this. I'm just going to draw a rectangle like that. Okay, the rectangle will represent the hydrocarbon. Okay, ready? Clear? All right, we go for this one now. Here we go for number 2. Also, again, you can see just now was 14. This is CH2 16. Saturate. Put a note here. Saturated fatty acid. Okay, ready? Okay, saturated fatty acid. Okay, again, same thing. Okay, so I'm not going to write all this because it's quite difficult with using my mouse. I'm just going to put a rectangle. The rectangle will represent this one. Can you see? Can you follow? The rectangle will represent this. So I'm going to put a rectangle here. Okay, another rectangle here. And another rectangle here. Same level with this carbon. Can you see now? Okay. That rectangle will represent your CH3 bracket CH2 bracket close bracket 16. Can you see that? Okay, then comes your COO, just like what we did just now. So you're going to put like this now. Okay, this one we use a tool, huh? Okay, this then continue C. All right, you can even put like this also can COO. Can you see? Or you can just put CO like what I did just now. Okay, here also continue the same thing. C double bond O. Okay, continue here, put a dash, C double bond O. Can you see that? Okay. Then, so COO. Can you see? Okay. C double bond O. Okay, sorry, it's the single bond. COO. Then continue with this. Okay, you put one dash, dash, dash. Carbon is here, the 3 carbon from the glycerol. Can you see? Okay. Then H is here, this carbon and carbon you join, this carbon and carbon you join, H is here, H is here, H is here. This again is another saturated. Then don't forget your 3H2O because H and OH becomes 1H2O, that's 3 times, okay, 3H2O. So you understand? This is one molecule of glycerol combining with or reacting with 3 molecules of fatty acid. This is another molecule of fatty acid. So this one is another rectangle I put. This one another rectangle here. That's how I told you, rectangle. Okay, all right, very simple. Okay, complete it first. The whole thing is a saturated fat. Now you understand now what is meant by saturated fat. It's actually an ester. Because you got the CO group there. Can you see? It's got the CO group here. CO0. Okay. So we'll clear. Can I clear my drawing? You copy first, okay? I'll give you a few minutes. Right? Because in syllabus they can ask, doesn't mean not always it comes out, but it is in syllabus they can ask. Okay. Ready? Okay. So now we go to the next one. All right. This is an unsaturated. Okay. So you see here. All right. Look at it here, please. Okay. Look at I'll put a small rectangle, please. Can you see that? Can you see a double bond there? Can you see? The moment you see one double bond, minimum one double bond between the carbon is so you put down here unsaturated fatty acid. Unsaturated USF. That's not saturated fatty acid. Unsaturated fatty acid. Okay, UFA. That's now was saturated SFA, saturated fatty acid. Okay, how you know that you can see a double bond there? Okay, so I'm going to put this. This is going to be my rectangle now. Okay. You can also put like a rectangle. Okay. So this is another rectangle. Now you're going to write so many times. Okay. So you're going to put 3 rectangles there. Can you follow me? The same thing again. The OH will react with the H from here. This is from the glycerol. Okay. So I'm going to put the rectangle on the same level. Your first rectangle, second rectangle, and third rectangle. Same level with the carbon here. Can you see now? Then continue with your dash. Okay, use your drawing tool. Okay, right. Put a dash there. Then your COO. Okay, we just put like this COO. Okay, no problem. You want to put double bond? Okay, COO. Here also dash COO. Can you see that? Here also dash COO. Okay, which is your carboxylate group. This one is COO. I erase it. I'll do it again. This one here. All right. Don't get confused. It's a dash C O and a O. Okay. Then continue with the carbon here. One carbon here. This carbon here. Put a dash there. Carbon all on the same level like this. Okay. One H here. Then join this link. All right. This carbon join like that. One H here. One H there. One H. Can you see that? And then don't forget your 3H2O plus your 3H2O. Can you follow me? Don't forget that. In biology, actually, this one we call it as condensation. Those who study bio, it's condensation reaction. Whenever water molecule is formed, condensation. Okay. So this whole thing is called unsaturated fat. This is the healthy fats, you know. So all right, the unsaturated fats are found in all the oils. Saturated fats are found in all the animal fats. Okay, copy that first. It's quite clear, huh? All right? How an unsaturated fat is formed and how a saturated fat is formed. Again, 3 molecules of this fatty acid, you see, this whole thing, 1 molecule of fatty, 3 molecules of this fatty acid combined with 1 molecule of glycerol. Understand, huh? When you study in bio, they don't show, you know, those who do bio, okay, they don't show how is this formed, you know, they just show the molecule of fat, whether it's saturated or unsaturated. But in chemistry, we go in more detail. But in bio, you don't say saturated fat, you say saturated lipids or unsaturated lipids. Is that clear, huh? All right. You copy first? Yeah, there's not much for this chapter. It's quite easy, but you know, you have to know, you have to understand. Okay, any question for so far? How you form, so you know what is saturated fatty acid, unsaturated fatty acid, okay? And then how you form a fat, 3 molecules of the fatty acids combined with 1 molecule of glycol. But if it's going to be a saturated fat, then you have 3 molecules of the unsaturated, of the saturated fatty acids combined with 1 molecule of glycol. If it's going to be unsaturated fat, 3 molecules of the unsaturated fatty acid combined with 1 molecule of glycerol. How you know it's unsaturated fatty acid? You see the double bond there between the carbon and carbon. Here, there's no double bond, all single bond. Okay, you understand, huh? All right. So I will clear and I'll go to the next part. Okay. All right. Then the next part is very important, huh? Okay. Now we have unsaturated fat. We are converting it to saturated. Now somebody will ask, sometimes students have asked me, you know, okay, I told them unsaturated fat is healthy. Is that clear? It's healthy fat. Saturated fat is unhealthy. Why? So why do you want to convert? You see the title here, conversion of unsaturated fat to saturated fat. What's the purpose of converting? Okay, so we do this because we want to produce substances like margarine. Understand? Margarine is like a paste. Remember, it's solid, huh? Okay? You can apply it on a bread. You can't apply oil on your bread, you know, correct or not? You see? And we use margarine sometimes for baking also, to make cakes, to make biscuits, you know. If you bake a cake using margarine and you bake a cake using butter, of course, the cake tastes better with butter. So some people, butter is quite a bit more expensive. So some of the poor people, they cannot afford butter means, then they use margarine. Is that clear? All right? And they use the planta margarine, you know, that is a cheaper version of the margarine. But you take planta and put it in the fridge, all right? And then because you don't put it in the fridge, after some time it smells, you know, it gets oxidized. So they put it in the fridge. Okay, and then they remove the fridge, it's hard, you know. You understand? You have to wait for at least about 10, 15 minutes for it to become soft again before you can apply it on your bread. You understand or not? Huh? That's why we use the soft margarine. So I'm converting this from unsaturated, which is oils, you know. Put a note here, unsaturated fat is oil. Saturated fat is solid fat because I want to make something like margarine so that we can be used for baking cakes and so on, or eating with bread and all that. So look at number 1. Most of the unsaturated fats exist as liquids, like oil. I told you just now, isn't it? Can we apply liquid fats on bread for breakfast? Answer is no. Put that note first. Okay. If you apply liquid oil on bread, then the oil will spill out. Correct or not? Okay. It won't taste nice. Okay. So put down just cannot. Okay. Can we apply liquid fats on bread? Put cannot. The reason, because the oil will soak the bread. The bread will become wet with the oil. Okay. So how do we solve this problem? Okay, put down first. Convert, all right, put down. Convert unsaturated fats into saturated fat. Right, that's your answer for number 2. Convert unsaturated fats into saturated fats, which are solids. You understand, All right, we convert unsaturated fat, which is liquid, to saturated fat, which are solids. Okay, so how we convert? We come to number 3 now. Unsaturated fat, which are oils, are converted to saturated fats, usually solids, by the hydrogenation process. Remember we learned hydrogenation? Alkene plus hydrogen, you get alkane. Correct, isn't it? That is hydrogenation. Temperature is the same, 180 degrees Celsius, and the catalyst is nickel. So you use the same thing here. So this is how they make margarine. You know, this is how they make margarine. They take the palm oil or any other, they even use, okay, olive oil, palm oil. Okay, they can even use other sunflower oil. Okay, and then what they do is they add it with hydrogen gas in the factory, small amount of hydrogen. That's an industrial process. Okay, all right, so you see here. So number 4, hydrogen is passed into unsaturated fat. Temperature, write it down, 180 degrees Celsius, using a nickel or platinum catalyst. So what happens is, just now I told you unsaturated fat has a double bond between a carbon, isn't it? So look at number 5. Hydrogen molecules will be added to the double bond. Can you see the whole thing is an unsaturated fat, the oil. So where the hydrogen will come and attack, here, can you see? Where I put the red arrow, there's one hydrogen will come here, one hydrogen will come here. When the double bond broken, it becomes a single bond. Then another hydrogen will come and attack here, and then attack here. So here will be H and H, here is H. Double bond becomes single bond. So this whole thing becomes a saturated fat, which is margarine. Are you following me? Very clear cut. So this one is important. All right, they'll ask you how to convert margarine. How do we convert oil to margarine? All right, the process is hydrogenation. What is the condition? They'll ask you. So you see from here, unsaturated fats from the vegetable oils, please. Okay. Unsaturated fat from vegetable oil such as palm oil. So most of the plantar margarine is made by using palm oil. Okay, or you can even use olive oil. All right, margarine containing olive oil, that is more expensive but is more healthy. Or margarine made from corn oil. Okay, or margarine made from sunflower oil. Can you see? All right. Like you see here, I just share this image. Can you see here? Can you see what is this? Sunflower oil. Sunflower oil they use, So this is healthy one, the natural margarine. This one, can you see here? This is a more expensive one. All right, it's healthy. Palm oil, okay, it's cheaper, but not as healthy as this one. Okay, for plantar margarine, they use palm oil. So you see a sunflower there, that means you use sunflower oil. You see olive symbol of olives down there, all right? It is olive oil. Okay, we'll come back, to what I do today. Just a minute, okay. Come back to this, So please highlight unsaturated fats from vegetable oil such as palm oil, or you can even put palm oil, or it can be sunflower oil, it can be olive oil or corn oil, can be converted to saturated fats like margarine. Name of process is hydrogenation. Because we are converting something from liquid to something solid, so that we can apply it on the bread or you put it in the mixture of the flour for making cake or biscuits or whatever. Understand? All right. Okay, it's quite straightforward, All right. Okay, then, in fact, we're actually coming to the last part already, Okay, this one is effects of fats on human health. Okay, now some of you might, especially those from the Graham Bell class, might not know because you're not doing bio, Okay, when you go for a blood test, sometimes, people say, I have a lot of cholesterol in my blood, Okay, doctor says my cholesterol is high. Sometimes you can ask your father will tell you that the doctor said my cholesterol is high, or another person says my cholesterol is normal. When I say high cholesterol, we're looking at this cholesterol. This is the bad cholesterol in our body. LDL, right? This is not the unhealthy cholesterol. And where you find this is found mainly in animal fats. Like, I give an example, You take the fat from the, chicken fat, satay, when you eat satay, all of you have eaten satay, isn't it? You take one chuchu of the satay, half will be meat, half will be the fat. Very seldom they put the whole thing as meat, unless you go and eat kajang satay. You eat kajang satay, you can see that almost 95% is meat, just a small part will be. But you buy the cheap satay, one about 70 cents like that or 60 cents, half will be the chicken fat, half will be the chicken meat, or beef fat and beef meat. Understand? So that is not good. The animal fats, they are unhealthy. They have high levels of LDL. This LDL, low density lipoprotein, have bad effects. Bad effects means I told you they will go and clog up. They will slowly form, clog up your arteries, especially the artery going to the heart, so that eventually when the artery becomes thicker and thicker and thicker with this fat, you find that the blood flow cannot flow to your heart, and then that's where you have a heart attack or you have heart disease. So this LDL is the bad cholesterol. One more highlight, HDL cholesterol. Okay, maybe your students from Graham Bell, they are not sure of this because they haven't learned it. This is a good cholesterol. This is found where? In plants. Okay, unsaturated, have good effects. Can you follow me? Okay. Yes, somebody is asking me something. Egg, okay. Egg. John is asking me. Egg. Egg yolk contains LDL. There is LDL in egg yolk. Okay. All right. Even the Indians and the Malays, even the Chinese sometimes, they like to use santan, santan coconut milk for cooking. Santan is safe. It's just coconut milk. But when you add santan to the curry and then you cook it, all right, the santan, all right, the coconut milk is converted to saturated fat. Not good. Understand or not? All right. So if you use a lot of santan in the cooking, it's not good, especially during old age. Okay, because saturated fats will build up. Okay, any other question on us? Okay, let me see first. What? Okay, all right. John, I think is Marcus, I think. Okay, all right. So LDL.
It's not
okay.
me.
Then who's John?
It's
Is
Carlo.
he an outsider or what?
It's Carlo.
Huh?
Carlo.
Carlo with John, warm boy. Okay, all right. Okay. Any other question? All right. Okay. So note it down. LDL cholesterol will deposit on the walls of the arteries and block them. LDL. LDL is an unhealthy cholesterol. Okay. All right. Any questions so far? No problem. So if you want to, you don't want to have, you must reduce on the intake of your saturated fat. All the animal fat, animal meat, red meat. You know red meat. All right. Red meat is all saturated fat. Please note it down. Red meat, all the red meat. Okay, white meat has less saturated fat. Chicken meat has less compared to red meat. You know what's red meat? Okay. All right. Then let's look at a few comparisons. This one is important. Saturated and unsaturated fat. Highlight. Consists of saturated fatty acids. Okay, saturated fat. And how you know saturated fatty acids? No double bond. All single bond between the carbon atom. Okay. Unsaturated fats have they're made up of unsaturated fatty acids, which contains one or more double bond. Remember I showed you just now, isn't it? Okay. And this one, if there's no double bond, the melting point is higher. Note it down. This is animal fat, higher melting point. Oils have lower melting point. Okay. There's another important thing. And this one is solid at room temperature. This is liquid at room temperature. Okay. All right. And this one, saturated fats cannot be hydrogenated because there's no double bond there. This one can undergo hydrogenation. Okay, and then this one is very important, high cholesterol content. Saturated fat, this one low cholesterol. Not no, put low there. Change no to low cholesterol content. All right? So the unsaturated fats are the more healthy fats, which are actually plant oils and all that. Okay? All right? if you like, some, there's many of the Greek Mediterranean countries, right? The Greek islands, all that, okay, Malta, all the Mediterranean islands, they are very healthy people, The reason is, okay, somebody is asking me, Joshua, is cholesterol a type of hydrocarbon? No, 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 no. Hydrocarbon only contains carbon, hydrogen. This is a fat, Joshua. It contains carbon, hydrogen, and oxygen. Okay, Kawan? All right. All right. It's not a hydrocarbon, huh? Okay. So many of the, Mediterranean islands, all the islands around Greece and all that, their people are very healthy there, And some of them, most of them, in fact, average lifespan around 70 to 80. Some even go even 90 because they do their cooking using olive oil, because olive is very cheap down there. Only when they export here to Malaysia, it's expensive, okay? But olive oil is very, very healthy oil. If you go to, let's say, Hero supermarket or any supermarket, it's expensive, okay? Because they crush the olive and they have the export, you see? Olive oil, so most of them do their cooking there using olive oil. So they are very healthy people. They don't have any heart problems and all this. Okay, yeah? All right? Well, they use a lot of olive oil, which is unsaturated. Okay, settle, huh? So now we come to just 3 questions and then we can call it a day today. Sorry to hear, yeah? Okay, let's go number 1. Let's look at the English part. What is the structural formula of a mono unsaturated fat? Mono means only one carbon chain. Okay, let's have a look. Don't worry if okay, mono or just look at the word. I want you to highlight the word unsaturated. Okay. Don't worry about mono, okay? They just give mono to confuse you, okay? All right. I want you to just highlight this part here. Unsaturated fatty acid. Remember the word fatty acid, huh? So let's check first. All the fatty acids got COOH. Can you see that? Okay, COH. This one also COH. This is also COH, okay? Who wants to try? Unsaturated. What do you think is the answer? Okay, so the answer is either, okay, somebody put the answer there. Okay, Sean put as D. Why you put D, Sean? You see, there's a double, okay, this one is wrong. This is saturated. Okay, cannot. This is saturated. No down here. Saturated fatty acid, saturated. Okay, so the answer is either A or D. Betul. Both also. Okay, check one. Yes. What's your question? Okay, let's see first, huh? Yeah, what's your question, check one? Okay, okay. All right. Now, you see, be very careful because this came out in 2008, You see here, why the word put mono, Mono means only got one double bond. Here you can see how many double bond? 2 double bond, so cannot. Understand or not? Huh? All right. So the answer is A. Only one is unsaturated fatty acid with 1 double bond. The fatty acids, the unsaturated fatty acid can have 1 double bond, even 2 double bond, even 3 double bonds. Okay. All right. So the answer is A. Okay. Then we continue. All right. Just one more question. Let me remove. Let's go next one, number 2. Okay, which statement is correct about, so this came out 2013, about fats and oils. It's not always they come out, huh? Okay. So what do you think is the answer? Fats and oils. What do you think is the most accurate answer? Sean, what do you think, Sean? You might not be doing bio, but you have to know because it's part of your chemistry syllabus. Okay, Sean says, okay, Sean Ken says B. Right? The answer is B. Yes, correct. Okay, why is A wrong? Jaing, try and see. Tell me why A is wrong. This SPM question, why is A wrong? Alim, try Alim. The answer is B, fat found in animals while oil found in plants, isn't it? Okay. All right. Alim, apa sebab A? Alim, want to try? Yeah?
What's the question, Jeff?
My question is, okay, the answer is number 2 is boy, huh? Okay, my question, why is A wrong? Apa sebab A salah?
Because some oils are
Usually oils won't lead to health problem. Only fats will lead to, because oils are healthy, unsaturated fat. You understand? Fats here we are talking to animal fat. So that's why A is wrong. Oils don't create any health problem for us. It's only the saturated fats, okay, from the animals. Okay. What about C? Okay, let's see. Let's ask. Okay, Satish, what do you think? Why is C wrong? Why is C wrong? Satish?
Because they are organic
You think?
carbon compounds.
No, not really. Elisa, want to try? Elisa Lee? C is wrong.
No, yeah,
Why?
I don't know.
Alicia? Want to try?
It's supposed to be fatty acids.
Well done, well done. That's a good girl. Okay, mixtures of fatty acid, not organic acid. Organic acid will be your ethanoic acid, butanoic acid, all that. That is your organic acid. You understand, huh? Okay, put the note. Okay, that's why C is wrong. Fatty acids. Okay, then D. Fats and oils are the same. They just, all right? They're not chemically different. So the most likely answer is B. Okay, huh? Right. Then we go to number 3 now. There's 2 more questions, then we can call it a day. Okay. Diagram 4 shows a process of preparing margarine from palm oil. I told you just now, isn't it? Margarine, palm oil, minyak kelapa sawit, you get margarine. Okay. What is process X? Anyone want to try? Yongsin, give me the answer for number 3.
Hydrogenation.
Well done. The answer is hydrogenation. Okay, the answer is B. Okay, good. This one came out 2013. And then this one another. Okay, but I told you that's not always it comes out. But it is most important. You can always set it. Okay, number 4. Sandra, try. Unsaturated fats can be converted to saturated fats. What process, Sandra?
Hydrogenation.
What's the answer?
A.
Answer is A. Okay. All right. So we only got 5 more minutes left. So any questions you want to ask for today? So that's all for this topic. Nothing much, All right. So we got 1 more chapter, that is rubber. Okay, the latex. That one more important, but that one every year ada soalan. Okay, even paper 3 comes out, paper 2 and paper 1. So rubber is more important. The latex, susu getah, that one is important.